Welcome back. This is the last section of this chapter 4, section 4.5, substitution rule. The thing about it is the lectures are a bit confusing or basically you learn a lot more in the substitution rule by doing the problems. So first, what I'll do is I'll go over the exercises mentioned in these lecture slides, and then I will continue with the lecture slide on page 16. Okay. Now, I have shared these lecture slides with you on Dropbox, so you should feel free to look at these slides for yourself, but I believe it's more useful to do the problems using substitution method, and then you'll understand things better, right? Okay, so here are the examples in the lecture slides. Suppose you want to find the integral of 2x square root of 1 plus x squared dx, right? So this is indefinite integral. We don't have any immediate formula that could be applied. But one thing to notice, 2x is derivative of 1 plus x squared. Okay, that's one thing to note. Something is derivative of something else. So let's play with that. Let u be 1 plus x squared. Then du dx is 2x. I'll move the differential dx here. Du is 2x times dx. Du is 2x dx. Aha, 2x dx is du. And 1 plus x squared is u. So this integration is integral square root of u, and the rest of it is du. So this approach is called approach of substitution. All right. The idea is you need to find some expression which will be u, and the rest of it should be du. So let's look at this. Integral square root u. Square root u is nothing but u to the power half. Its integral you know. Increase the power by 1 and divide by the new power plus some constant. Half plus 1 is 3 halves. 3 halves. Division by fraction is multiplication by the reciprocal. So that gives me 2u to the power 3 halves over 3 plus c. But my question was in terms of x. So my answer should be back in terms of x. Where is u? U is 1 plus x squared. So resubstitute back and you're done. That is your integration. It's much easier than trying to figure out some product rule, etc. Okay, let's try one more example. Integral x cubed cosine of x to the 4th plus 2 dx. Notice this guy, its derivative is this. You see? So that's our hint. You found something whose derivative was the rest. So let u be x to the 4th plus 2. So du dx is 4x cubed. Aha, I don't want a 4. There is no 4. So let me divide by the 4 and get the differential dx here. So that tells me du over 4 is x cubed dx. X cubed dx. So this expression, integral x cubed cosine x to the 4 plus 2 dx, is cosine of u. This is du over 4, right? x cubed dx is du over 4. Now, integral of cosine we know. It is sine u. Over 4 is just a constant. Either multiply or divide, it continues. Plus c. Question was in terms of x, so you need to replace u by x. Sine x to the 4th plus 2 over 4 plus c. Alright, so this was a much straightforward integration once you detected the expression that needs to be your substitute variable. Okay, this approach is very useful even when you're looking at definite integrals. 0 to 4 square root 2x plus 1. Alright, so I'll call 2x plus 1 u. Now there are limits here, so I will have to find limits for u as well. So when x is 0, x is the running variable in my original expression. So this means x is 0 to x is 4. So when x is 0, I plug in for u and I get u is 1. Right? 2 times 0 plus 1. When x is 4, 2 times 4 plus 1, u is 9. Alright, now take the derivative. Du dx is 2. That means du is 2 times dx. But I don't want a 2 outside. I simply need a dx. So dx is du over 2. So this original integration 0 to 4 radical 2x plus 1 dx is new limits. 0 corresponds to 1, 4 corresponds to 9, and square root 2x plus 1 corresponds to u, and dx corresponds to du over 2. U, square root u is nothing but u to the power half. When I take integral, I increase the increase the power by 1 and divide by that new power. Don't forget there was a 2 already. Now that I have taken the integration, I write 1 here and 9 here to represent I'm going to evaluate this expression at these numbers. This evaluation first minus this evaluation next. Let me simplify the object inside first. Half plus 1 is 3 halves. Half plus 1 is 3 halves. Division by fraction is multiplication by the reciprocal. So 2 upstairs and 3 downstairs. This 2 continues to be this 2. They cancel. Once they cancel, all you are left with is u 3 halves and 3. I want to evaluate it at 9 first, minus evaluate this at 1. What's the meaning of 9 to the power 3 halves? Square root of 9 power 3. Square root of 9 is 3, power 3 is 27. 1 to any power is 1. Over 3 over 3. So in all, 26 over 3. Alright, so I'll stop with these examples. These examples have been covered in this particular slide all the way until page 16. Okay, so I'll continue next video, page 16.